Welcome to Daily Papers, the podcast where we break down the latest and greatest in academic research, making it easy for everyone to understand.
Today we're talking about AI memory. You know how you can chat with an AI assistant like ChatGPT and it remembers what you said a few minutes ago?
Right, that's super useful, but what happens when that conversation isn't just text? What if you send it photos, screenshots, voice messages, and then weeks later you ask a question about one of those things?
Exactly. You'd expect it to remember, but a lot of the time it just can't. This is a huge problem because our conversations with AI are becoming more and more multimodal, a mix of different types of media.
And a new paper from researchers at the University of Texas at Dallas and the University of Florida is tackling this head-on. It's called V-Mem, Modality-Routed Retrieval for Long-Term Multimodal Agentic Memory.
It's a fantastic name, and the system they've built is even better. But first, we need to understand why current AI memory systems are so bad at this. The researchers say it boils down to two main problems, which they call gaps.
The first one is the modality gap. Modality is just a fancy word for the type of content, like text, image, or audio. The modality gap is the simple fact that it's really hard for a computer to compare two different types of things.
Think about it like this. If you ask a text question like, "What kind of plant was in that photo I sent you last week?" the AI has to compare your text question to all the images in its memory. To a computer, that text will always seem more similar to other text than to any image. It's like trying to find a match for an apple in a bin full of oranges and other apples. The AI will just keep pointing at the other apples.
It gets stuck in its own lane or its own modality. But even if it could easily compare text and images, there's a second, more subtle problem, the similarity relevance gap.
This one is my favorite. It says that the thing in your memory that is most similar to your question isn't always the thing that answers your question.
Okay, you've got to give me an example for that.
The paper has a great one. Imagine you send your AI a photo of the Google headquarters and ask, "What did we discuss about the organization shown in this image?"
Okay, so I'm asking a text question that comes with a photo.
Exactly. A simple AI search would do two things. First, it would search for similar images. It would find all the other pictures of big, modern buildings you've sent you. Not helpful.
And second?
Second, it would search for similar text. Your question has the word organization in it. So the AI would find every conversation you've ever had about any organization, like your kid's PTA or a local charity. Also not helpful.
Right, because the relevant piece of information might be a text message from 3 weeks ago that says, "Hey, Google is giving students a free subscription to their AI service." That text has nothing in common with a picture of a building, and it might not even use the word organization.
That's the similarity relevance gap in a nutshell. The most similar stuff isn't the relevant stuff. So how do we fix this? This is where the paper's solution, V-Mem, comes in.
V-Mem is a new kind of memory system, and it has a couple of really clever tricks. The first is how it organizes the conversation. It doesn't just throw everything into one big pile. It groups the conversation into rounds.
A round is just one back-and-forth exchange. You say something or send an image, and the AI replies. That's one round. The logic is that things that appear in the same round are probably related to each other.
It's like putting a photo in an album and writing a little note right next to it on the same page. To find the note, you just find the photo first. This is how V-Mem crosses that first problem, the modality gap.
Let's go back to the plant example. You ask, "What species is in the photo?" V-Mem first searches its image memory and finds the right photo of the plant. But instead of stopping there, it just pulls up the entire round that the photo was in. And right there, in the text of that same round conversation, is the answer. "The seller told me it's an Echeveria." Problem solved. It never had to directly compare your text question to the image pixels.
That is so smart. It uses the context of the conversation itself as a bridge between images and text. But what about the other problem, the similarity relevance gap?
For that, V-Mem has another trick. It uses an AI to generate a better search query, which the paper calls a search anchor.
So it's improving its own search.
Precisely. Let's say you ask a text-only question, like, show me the picture in our conversation that is about friendship. The word friendship might not be in any of the captions. A normal search would fail.
So what does V-Mem do?
It sends that query to an LLM and asks, what would a hypothetical caption for this image be? The LLM might generate something like, friends gather around a campfire, smiling and playing. V-Mem then uses that hypothetical caption to search the image memory. And boom, it finds the picture of you and your friends around a campfire.
It's basically reverse engineering the search term it wishes it had. That's brilliant. What about for the Google headquarters example, where the query has both an image and text?
It does something similar, but in reverse. It shows the image to a vision AI and says, extract the most important keywords from this picture. The AI will look at the photo of the Tesla and say, Tesla, car, Elon Musk. V-Mem then adds those keywords to the original text query. This creates an enriched search anchor.
And that new, enriched query is much more likely to find the conversation where you were actually talking about Elon Musk and Tesla.
You got it. It combines the clues from both the image and the text to create a super query that can find information that neither part could find on its own.
So the big question is, does it work?
Oh, it works. The researchers tested V-Mem against other state-of-the-art multimodal memory systems, and it blew them away. On questions that involved an image, V-Mem scored an 87% success rate, while the next best system couldn't even get past 47%.
Wow, that's not just a small improvement, that's a massive leap.
It is. And what's even crazier is how efficient it is. Other systems spend a lot of computing power trying to summarize and process conversations into a neat little memory graph. V-Mem doesn't do any of that. It just saves the conversation as is, which means building the memory is practically instantaneous and free.
So it's smarter, faster, and cheaper. This feels like a really big deal for the future of AI assistants.
It is. As we continue to blend text, images, and audio in our digital lives, we need AI that can not only understand these different modalities, but also remember them together as part of one long, continuous conversation. V-Mem shows us a powerful and elegant way to do just that.
A great paper that really makes you think about how AI memory should work. That's all the time we have for today. Thanks for tuning in to Daily Papers.